So in this video, I want to quickly look at the concept of MCP, also known as Model Context Protocol. And on my screen here, you will see the initial announcement from Anthropic, which was made around 25 November last year, as 2024. And if you don't understand what MCP is and what it is about, this video is for you. So we're just going to quickly look at why it came about and what problems it aims to solve. So if I scroll down this article and read what Anthropic is proposing with this protocol, as you know, a protocol is really just a standard set of rules that one or rather two or more parties agree to follow so that the communication between them or among them can be more predictable. And for example, this is very useful in networking systems where we need multiple computers to be able to send and receive messages. And one of the most famous protocols in this regard would be the HTTP protocol, which is the technology behind most web applications. So similarly, the model context protocol is a new standard for connecting AI assistants to systems where data lives, including content repositories, business tools, and development environments. If you are not sure what that means, don't worry about it. We're going to dive deep into what that means exactly. But before we do that, I want to take you back to another announcement, and this time by OpenAI. So OpenAI is another provider of AI models, and they released this feature called function calling going back to June 2023. And at the time, they proposed that in order for us to enable LLMs to interact with external systems, we need to introduce a way to tell these AI models about these tools, where they live, how to call them, and then the tools or the model will decide during the completion whether to call these tools or not in order to enrich its context. So to put this into perspective, let's look at a concrete example. So we're just going to go through a bit of a code example provided on the link shown there. We'll also paste it in the description. And you'll see here that the idea is actually very simple. So in this case, we have selected this getWeather function, or this getWeather system, which is an external system that we want our AI model to know about. And basically for us to tell our AI model about this external system that it has access to, we follow a schema that looks like the one provided here. And you can read through this documentation to get more information about the specifics of the schema, but that's not the purpose of this video. But what I want to show you here is, for example, if I ask, what is the weather like in Paris today? And because you've told the model that, hey, you do have access to this tool, and either call it, you can refer to it as a tool or a function. And so when the model tries to answer your question, it can then say, oh, in my tool registry, there is this function that I can use to get the weather. So whenever a user asks a question that requires some updates about the weather, I can use that to get the information on behalf of the user. So the syntax here is not important, but basically what the model will do, instead of returning the response here right away, what it will do is it will say, okay, I'm returning this directive with a type called function call. And with this directive, I'm expecting the programmer to actually execute this function and send back the results to me. And then I will use that additional information to give a final response to the user. I hope that makes sense. If it doesn't, please look at another example here, like a send email function, which basically does the same thing but takes a different set of parameters. For example, in this case, it takes the destination, the subject, as well as the body. And it does the same thing where it says, okay, the prompt here is saying, can I send an email to these two people? So natively, the LLM doesn't know how to send emails. But because we've enriched the LLM with this tool registry that contains this function called send email, it will then say, oh, I want you, in the response, it will say, I want you, the programmer, to run these two functions and then send me back the result so that I can respond on whether the email is sent or not. So in a nutshell, that's function calling. And I hope that is clear from these examples. And basically what you're really trying to do here is to say, okay, LLMs are great. They allow us to ask questions and get human-like responses. But then can we actually make them do stuff that's more than them just answering questions? So basically that's what we're doing with function calling. So how does the MCP or Model Context Protocol come in? So the challenge with function calling in its native form is that the syntax of specifying the tools available to the model can vary from one provider to another. As you know, OpenAI is not the only company that provides AI models. There are many companies that provide their own models, and some support function calling, some do not. And the syntax of configuring the LLM to talk with external tools varies from provider to provider. So the model context protocol is basically saying, okay, let's come up with this standard set of defining functions that an LLM can access, and let's all implement clients that can interact with tools that are defined in this format. And if I go a little bit deeper into the documentation, the link for this will also be pasted in the description. And if we scroll down to the general architecture of the model context protocol, you will see here that the idea is actually very simple. So you have 3 or 4 main components when talking about this protocol. You have the client, which runs on a host, and then you have the protocol, or the also called the transport protocol, basically how the communication between this client and the server occurs. And then you have these resources here, which could be web APIs, could be databases, it could be just plain documents in PDF or Word format. So basically now what we've done is say, if inside your client you implement protocols that allow for the connection of these external servers, which hosts tools that enrich your AI models to access external data, then your implementation, your tool implementations should work irregardless of the model you're using or the host that you're using. So one of the things that's a bit confusing, and it was confusing for me, was the concept of MCP hosts. So they define MCP hosts here as programs like Cloud Desktop or other integrated development environments or IDEs or AI tools that want to access data through MCP. And you will see from the diagram that the hosts will typically contain one or more clients to maintain connections with your MCP service. So to summarize, inside your MCP server, this is where you will define your tools. And then your client, which if you're using something like Cloud Desktop, it already contains a universal implementation that allows you to plug and play any MCP server. So your client will be able to use whatever tools you define in your service. So as you can see, you can connect to one or more servers which access different kinds of resources. So I know this might be a bit confusing. So I also have here one of the official MCP servers, which you can test this idea out with. So it's the Spotify API, and you'll notice in here that basically this is built on top of the Spotify developer API. So if you want to, for example, start or pause your music, search for playlists, get information about artists or playlists, you can do it using this MCP server. So you can imagine that, for example, from your Cloud desktop application, you can then just in your chat session, you can just tell Cloud to start playing a certain track or search for a certain track, etc. So just to dig a bit deeper, let's have a look at how an MCP server is implemented, right? So first you will see here in this code base that we have a module here called Spotify API. And if I open this, I notice that this is defining some variables here to authenticate the user using OAuth 2, and is defining the scopes that you are going to need to access the different endpoints in the Spotify API. So this just allows you to specify in simple terms what permissions you are going to need to perform the different operations. So for example, if you need to read the current song that's playing, for example, you will need the scope in your OAuth 2 request. This is not an OAuth 2 tutorial, so I hope that makes sense. And just to browse through this quickly, you will see that we have a whole set of methods here which actually call the Spotify API and return the results. So you have this search, recommendations, get the current track, etc. So this is, in this case, this would be your external resource that we refer to from our MCP definition. So this is the external resource that you want the AI model to communicate with. So now, if I go back and open this server.py function or module, you will see that we are importing that API, meaning that we are bringing in all those functions that will interact with the Spotify API into our MCP server. And inside the server, basically the most important thing is for you to actually handle requests to call different tools from an AI model. So basically, when the client that you're using, your MCP client, decides that it needs to call a certain tool that you have notified it about, it will then say, okay, please call the tool with this name using this argument. And this will be a dictionary containing the arguments that you specified in your tool specification. For example, if I go back to the email example, your arguments will contain a dictionary with keys to, subject, and body. And each of these will have a value that the LLM will decide on. And I'm using the word LLM and AI interchangeably for the sake of this video. I hope that's not causing any confusion. So getting back to the implementation of your server, then you will then do some sort of a switch case or an if else if you prefer. In this case, we're using the match case syntax, which is available in recent versions of Python. But think of this as an if else statement basically that will check. So this basically this function, this is where you as the developer of the MCP server will need to come in and handle this request that will come from your client. So basically this is probably the most important part of your server. And let's just look at one example here where if so we're trying to match here the name of the tool, and you will see here that we're saying if the name of the tool that we are asked to call is called playback, we check for the action that is included in the argument. And then, for example, if the action is get, what we want to do, so if the action is get, what we want to do is to simply use our Spotify client wrapper, which we looked at before, and call whatever API will call the API that allows us to retrieve the current track from the user Spotify account. And the same logic applies for the other cases as well. So you'll see if the name of the tool is search, you do the same. You extract the parameters of the actual API call, and then do the API call, and then send back the result of the call to the LLM. And you need to actually follow the response protocol as well, so that any LLM knows how to deal with the result of your tool call. And in a nutshell, this is it. I know it sounds more complicated than it really is. So just to recap, the model context protocol, if I go back to this general architecture here, so the model context protocol allows any LLM to interact with external tools using a set of predefined standards for communication. And we say this is important because each LLM provider may implement function calling in a slightly different way. And in addition to that, the LLM framework you are using may also implement function calling in a slightly different way. So the MCP is there to sort of standardize the way that any LLM or any LLM framework interacts with external tools or resources. And we said your resources could be an external database or documents, or it could be other APIs. So if you've worked with the RAG before, this is a very similar concept, because even here we are enriching the context of the LLM so that it knows exactly what we want. And the only difference between this and RAG is that in this case, because we are actually interacting with external tools and not just reading data from them, we can actually then instruct our LLM to do things on our behalf. which is what we saw in this example given by OpenAI, where we can then tell the LLM to use this function to send emails to the specified users. So for further reading on MCP, visit the model contracts protocol.io, and I think a good place to start would be to look at this example servers. As we saw, we went through the Spotify MCP server, and you noticed how easy it is actually to implement your own server. So the other advantage of having this standardized way of communicating with external resources is that now we don't have to keep implementing the same tools. So if you wanted, for example, to use something like, let me see if there's something familiar here, there's Stripe. So if anyone wanted to create a chatbot that can make Stripe payments, now you can just come and use the standard server. There's no need for you to implement your own, because this server will work with any AI application that implements and supports the MCP protocol. So I hope that was useful. And if there are any questions, leave them in the comments, and I'll try and make a follow-up video to address any gaps. And until then, keep well. Thank you.